My subject is energy analysis of a power plant operating with organic Rankine cycle and refrigeration cycle. Firstly, ideal organic Rankine cycle. So the diagram shows as the main component of the organic Rankine cycle, and the graph shows us a temperature entropy diagram of it. So as what you see on that graphs, network and thermal efficiency were shown, which related to condenser pressure, boiler pressure, and the boiler temperature respectively. When we investigate first graph, while the condenser pressure were changing 10 to 5000 kilopascal, boiler temperature kept at 600 Celsius, and boiler pressure kept at 50, 80, and 110 megapascal respectively. What we observe from the graph, xenon has a higher efficiency than the other fluids, and the ammonia produce more network than the others. When we observe the second graph, it shows us a boiler pressure discrimination, and the third one shows us boiler temperature graph. The second one is irreversible organic Rankine cycle. Irreversible cycle has the same characteristic like the ideal one. However, isentropic turbine and pump efficiency affect the cycle. And on graph 1, we can easily see the turbine effect of the thermal efficiency, which while the turbine efficiency were increasing, thermal efficiency goes with it. So the pump efficiency were increasing, the thermal efficiency goes down with that. We can easily see the difference between ideal organic Rankine cycle and irreversible organic Rankine cycle on it. So when we investigate irreversible organic Rankine cycle, irreversible organic Rankine cycle produce less network than the ideal one, and its thermal efficiency also less than the ideal organic Rankine cycle, which is more closer than the real life. And the third one, ideal organic Rankine cycle with reheating. In reheated system, there is additional turbine, which we call it high pressure and low pressure turbine. Actually, Rankine cycle with reheating has same characteristic like the other ones. However, it increased the thermal efficiency a bit, and it also increased the network because of the additional turbine. The fourth one is the ideal organic Rankine cycle with open feed water heater. In open feed water heater, there is one turbine. However, steam extracted from turbine and it goes to open feed water heater. So it has also same characteristic like the other cycles. However, while it was increasing the thermal efficiency, network decreased a bit because of the additional pump. And lastly, for ideal organic Rankine cycle, it's combined system, which is with open feed water heater, closed feed water heater, and there are also 2 turbines and 3 pumps, what we seen on the graph. And firstly, the condenser pressure were changing 10 to 3000 kilopascal. We observe network and thermal efficiency, while the other parameters kept constant. In second graph, I changed open feed water heater inlet while the other parameters kept constant. And the third one, I changed the closed feed water heater inlet, then while the other parameters kept constant. In third one, like the other cycle, boiler temperature changed from 350 to 900 Celsius, while the other parameters kept constant like the others. And the fifth and sixth one is the new one, which is Y is changed from 0.1 to 0.9, which is steam extracted from the high pressure turbine, and Z is value that change from 0.1 to 0.5, which means steam extracted from the low pressure turbine. And last system is ideal refrigeration cycle, which we can observe the main component of the system, and we also can see the main temperature entropy graph of it. So firstly, I change evaporator pressure from 10 to 3000 kilopascal, while mass flow kept constant at 0.05 kilogram per second. At the same time, condenser pressure kept at 3.5, 4 and 5 megapascal respectively, and we observed that ammonia produced more network than the other fluids, and also ammonia produce more coefficient of performance than the other ones. And after that, I changed the condenser pressure while I kept other parameters constant, and I observed that while the condenser pressure were increasing, ammonia produced more work than the other ones. However, when we investigate coefficient of the performance, the carbon dioxide coefficient of performance more than the other ones. Lastly, I investigate mass flow change. At what you observe from the graph, while the mass flow were increasing, all of the fluids inlet network increased also. Have a good day.